okay, let me continue. Next one, we want to know confidence interval, hypothesis test, and finally to have some other results. And for this one, let me go through a bit quickly. Confidence interval. Actually, confidence interval, if we have a graph like this, sometimes you will see someone that have a bar. And this bar we call confidence interval. And actually, you can find confidence interval from Excel. Excel that you have the calculation, so that it won't be necessary to use the formula. But for us, actually, we don't have the formula. If you don't use Excel, for example, if you use MATLAB, you can use your own formula like this. Well, we have two ways to have confidence interval. If we have normal or we have t distribution. Well, first of all, n sample size sufficiently large. Then an approximate this one, this percent. For example, 90%. All right, 90% confidence interval. Follow this expression. As for parameter here, we will know later. And here is sample variance. Of course, sample size. And a parameter z. Z through lookup. So later we will look up a table so that we can have the value z. Well, how to have the confidence interval? So we may have some problem. And because of the problem, we expect to have large enough n. I just didn't know this. As for scale the underlying distribution, for this one, maybe let me scale it temporarily. Well, again, we assume IID. Again, this is assumption again. IID, and the IID then, if you can use the concept of central limit theorem. So central limit theorem, in fact, we just care about mean. If we have a random variable, A, and central limit theorem care about this, A minus its mean, and over square root of a variance. Then this follows normal, and specific normal with zero mean and univariance. And this is normal. And we want to have this one follows. We want to use central limit theorem, but it doesn't mean we use central limit theorem directly. So here, this is central limit theorem. So central limit theorem, we want to have this random variable again, and this random variable again if we have a large enough sample size, and then this one follows normal. And what kind of normal? This one and this one, standard normal. Actually, this. Zero mean and univariance, so standard normal. So this time, we want to know this. We can try to find the new observable variable. Here we define this. And define this so we can have this one. And right now, we already have a sample mean. Previously, we know sample mean with the mean here, with the variance here. So that's why we observe this. Is it okay? Previously, we have the fact. Sample mean with the mean mu with the variance sigma squared over n. So of course, we can define z sub n here. Because of this way, central limit theorem, in fact, we want to care about a given variable. A given variable minus its mean over its standard deviation. That's a square root of a balance. And so that we can reach the central limit theorem. So that's why we use this way to define z sub n. Well, up to now, we have the description for central limit theorem. And also, we already have the reason why we want to define using this way. Well, about the current discussion, maybe I go through quickly. But the other thing about this, of course, allow you to have the discussion with your neighbors. So, sure, you can have the discussion or chatting with the person next to you right now about the current discussion why and how to have some results. Think about this. I just want to make sure right now you can know what I want to pass to you. Well, think about this. Of course, right? Let me randomly nominate some of you to know your status. So, dear, is it okay? While I talk to you, dear? Dear? No responses. Little Evan? About the current discussion? No. Alice, understand what I talk to you right now? Understand? You don't know? But Dad, understand? So talk to Dad. Evan? I'll talk to Dad. And Eugene? In fact, let me go through this quickly.